Let us try to understand what is data science, what is machine learning, and what are we going to discuss in this course. There's a supermarket called Target. It's the US third largest supermarket. There was one data science incident that happened in Target that even came in the news. You know what was that incident? There was one gift pack that was sent to a woman in US. Along with that gift pack, there is a card. On that card, it was written, "Congratulations, you're pregnant. Please take care of yourself," etc., etc. was written on it. And that woman got totally shocked. Do you know why? She did not reveal it to anyone that she was pregnant. Nobody knew that. She did not tell that to anybody. But how come a general supermarket like Target, they came to know that she was pregnant? Can you make a guess? How did they do it?
Prediction.
How did they
Purchase
predict?
history.
How
Based
did
on
they
her
predict?
Based
purchase.
on her purchases. They made
Exactly. Basically, what Target has done, you guessed it correctly, these retail supermarket companies or retail companies, e-commerce companies, they take the customer data, they analyze the data before sending any marketing campaign like this. They don't sell, I mean, it doesn't make any sense to send these gift packs randomly along with the gift cards. It doesn't make any sense, isn't it? So what do? They take the whole purchase data, they hold the customer data, divide these customers into various segments or various groups. In marketing, there's a rule that one size doesn't fit all. You cannot send one marketing campaign to all the customers. You have to divide them into various segments or various subsets. Maybe these are all the customers with very less age, maybe very less income. These are all the students. Maybe these are all the customers with a certain age, who are falling in a certain income band. These are all the customers from a certain region. These are all the customers based on their purchase patterns. It looks like they are kind of at the early pregnancy stage. These are some other type of customers. Do not apply one strategy on the full data set. Divide them into various segments or the subsets. Understand, study each customer segment. Try to apply a strategy that will suit best for that particular subset so that they can feel connected to. This is known as customer segmentation. Customer segmentation is the final application, but behind the scenes, to do this customer segmentation, we use a machine learning technique called decision trees. Basically, decision trees are applied to do the customer segmentation that will indeed help us to build the strategies like this. In fact, in this course, we are going to discuss what are decision trees. How do we actually take the data and get these customer segments? And once we get the customer segments, how do we build the strategies like this? How are the marketing strategies rolled out? How are these customer segments built? That's what we are going to discuss. This is one of the example of the application of the data science. And there are so many other applications. All of you must be aware of them. Other application is credit score calculation. If you apply for a loan in India, if you apply for a loan, what is checked?
CIBIL score.
CIBIL score, isn't it? CIBIL score will be verified. CIBIL score is also known as credit score. Based on the customer historical data, how many loans the customer has taken, how many times the customer has made late payments, what is the customer monthly income, what is the customer monthly utilization percentage, how much he owes, how much is the overall balance that he has in terms of loans and all that, how many credit cards he has, how many times he applied for the credit cards. Does that matter? A customer applied 30 times in last 2 years, another customer applied for a credit card only 2 times. Tell me who is going to be risky?
30
So the one who
times.
applied 30 times.
Why he is risky? He's credit hungry, isn't it? That is why applying multiple times is also a big issue. Don't think that if somebody is rejecting me, if I like, it's not just credit card. I'm talking about loans. If you're applying for loans for too many times, that is also act against your score. This whole thing is calculated by using CIBIL score. CIBIL score is the final application. But to calculate this CIBIL score, we use a machine learning technique called logistic regression. Logistic regression is the machine learning technique. In fact, in this course, we're going to discuss logistic regression in depth, understand all the nitty-gritties, nuances of logistic regression. Then we see how do we build the credit score. In fact, a lot of you will be doing this exact same project of building the credit score using all these variables. I'm giving you a few examples of the variables, but in reality, there are so many variables. We'll be working with that. That is another application. Detection of fraud transactions based on the time that you have swiped the card, based on the amount that you have swiped, based on the number of times you have swiped on that given day, based on the vendor Are you swiping it at an airport? Are you swiping it at a grocery store? Are you swiping it at a online e-commerce, online or offline? Where are you swiping? When are you swiping? Is it 3 a.m. in the morning that you are swiping? Is it 5 p.m. in the evening that you are swiping? Based on all this data, we would like to predict whether this transaction is fraudulent or non-fraudulent. If it is fraudulent transaction, if it is predicted like that, even if you enter the right pin, sometimes the transaction is rejected. Have you ever seen that? Have you ever faced it? You entered the right pin, but still the transaction did not go through.
Sure.
Yeah, that is happening behind every transaction. There is this fraud score calculation that is happening in YouTube recommendation, in self-driving cars, in marketing and sales, customer segmentation, product recommendation, in insurance. Everywhere there are so many example applications of data science. I think all of you must be aware of all these, isn't it? We are seeing these data science applications in day-to-day life. We are part of it. The kind of calls that you get, do you think everybody getting the same marketing calls? Different people will get different marketing calls, isn't it? The kind of calls that you get, somebody from some other village, he may not be getting the same calls, because before making a marketing call, we check whether the customer has higher chance for responding to that marketing call or not. If there is a chance for you to respond, then only you will get that call. Okay. So what is the data science? Data science is data-driven decision making. Data science is data-driven decision making. Building business strategies based on data analysis. You're not building it manually. We want to remove that manual or judgmental error. I don't want to build any strategies manually on my own or on my own experience. Here, our past experience is historical data. Our historical data is our past experience. Based on the past experience, we want to build the future business strategies. That is known as data science. What is data science? Data-driven decision making. Data science is also known as data analysis. Data science is also known as data mining. Data science is also known as predictive modeling. Data science is also known as machine learning. No matter what you're calling, what is the underlying process? You take the data, you find the patterns in the data, use those patterns to build the future business strategies. Don't you think this is the process? Look at this, all of you. Take the data, find the patterns in the data, use those patterns to build the future business strategies. You can name it as data science, you can name it as data mining, you can name it as predictive modeling, whatever you name it. This is the underlying process. There are different terms that are used, but the underlying process is this. Don't worry about what is it named as. This is the actual underlying process. Even new terms will also come up. Do you believe in that? The same thing would be called as cognitive thinking or cognitive intelligence. Have you heard of these terms? Newly they are cropping up, isn't it? The same thing would be called as some other name. Yeah.
Yes, sir.
So no matter what is the new name that will come up. In fact, when I started working, there was not even the term data science. Data science was not existing. Only it came only a decade back. Only from 2012 onwards, data science started appearing. Data science, or 2010 onwards. At that time, like when I joined a job, it used to be called as predictive modeling team. The same data science team right now used to be called as predictive modeling team. Got it? Let me pause here, take some questions on whatever we discussed until now. Any questions?
Yes, sir. Regarding that fraud analytics,
Yes.
like there are a lot of questions that arrive in the interview regarding fraud analytics.
Yes.
Like a question that I faced, that they have asked me that suppose you and you have a friend and there are two guys in a group. So you and your friend card is being stolen. How will you analyze that this is a stolen card and this is a fraud call for the team? How will you analyze the data? How will you look after it?
So basically,
So
fraud teams.
So I told them that I'll look after the transaction history of that person, that guy, and what is the transaction history, but they were not satisfied with my answer.
So basically, the fraudsters that they do the fraud transactions, okay, they are much more smarter than the actual data scientists. Okay, they keep on updating. Let's say you build one strategy, you build a model to predict whether it is going to be a fraud transaction or not somehow. Okay.
Yes, sir.
Now these fraud guys will identify that, and what they'll do, they'll do some other fraud thing, which is bypassing your model. Are you getting what I'm trying to say? Your
If
model will
they'll
not
change a little bit, the model will be failed. They'll just,
like they will keep on doing something new so that like your model will not identify. So these fraud guys will keep on updating them. They're very, very creative. That is why if you are getting hired for these fraud teams, instead of checking the actual model building ability, instead of checking your machine learning ability, The recruiters or interviewers are checking your creative thinking.
Okay.
They want to see how creatively you can think to capture the fraud guys. So in those interviews, it's not the actual machine learning related answer they are looking for. They're looking for something very like they're looking for a spark. Like if you give that answer, they should feel, yeah, like that is something that will quickly work. If you say my friend has a PIN number and the other fraudster, he may not have PIN number, those are very, very lame answers. They are looking for something, a very creative answer. Okay.
Yeah, I've explained them about the criteria. If he's working guy, he's in corporate.
Right. So basically, what I'm trying to say is there is no right answer there. It is just about they're checking your creativity. It is almost like a puzzle that they have asked. Okay.
Got it. Got it. Sir.
All right. Now, if you want to become a data scientist, there are 3 major skills that are required. Complete data scientist I'm talking about. Database handling skill, analytics and machine learning skill, presentation skill. When I say database handling skill, you should know how to manage the data, how to do the data blending, data model, data querying, data manipulations, ETL, SQL, structured query language. That is the first aspect. The second aspect is you should know analytics and machine learning, basic statistics, mathematics, predictive modeling, machine learning, and all that. The third aspect is presentation skill, storytelling skill, data visualization. You do a lot of analysis here. How do you represent in such a manner that the end user will get to understand it very easily? Report design, insights presentation, etc. These are the 3 major aspects to become a data scientist. Okay. Now, what are the tools inside each of these? The tools and techniques, database tools are MySQL, SQL, Teradata, DB2, Oracle, Informix, Exadata. Database handling tools, there are so many tools, isn't it? Obviously, it is not required that we master all these tools. It's impossible. At least the topmost ones. At least you should be very good at SQL. The second one is sometimes the data is in CSV files or Excel files. At least you should be good at Excel and SQL, because not every situation your data will be only on SQL. There are some teams where the data is maintained on CSV files. You'll be mostly working with Excel as well. You'll be handling the data either Excel or SQL. The second aspect is the analytical part. The analytical tools are SAS, R, SPSS, Python, Weka, MATLAB, etc., etc. SAS used to be one of the most widely used tool around 10 years back or 6 or 7 years back. SAS used to hold 95% of the analytics companies used to use SAS. Now, slowly they have lost the market. Now also SAS is falling around, I think I would say 30 to 40% of the companies are using SAS now. But there is this tool that gave very big competition to SAS, that is R. But afterwards, a lot of companies replaced R with which tool? Nowadays, the most prominent one that is really in the market is Python. I think you may have observed that, isn't it? That whole transition, some of you may have observed. So if you say what are the top 2 tools right now, I would say Python followed by SAS. Okay. Then the presentation tools or the data visualization tools are sometimes you can create the dashboards in Excel itself, isn't it? Excel, Power BI, Tableau, ClickView, Spotfire. Again, half dozen more tools are there. Again, we have to go with the topmost ones because it's impossible to master every tool that is given here. So Power BI and Tableau are the top 2 tools. If you observe it carefully in our course design also, we are focusing mostly around these, isn't it? Have you observed it? It is Excel, SQL, it is SAS and Python, it is Power BI and Tableau. These are the ones that are the critical tools for us to attend all these interviews, isn't it? Because this is where the whole data science world is revolving around. These are all the, and this is where most of the jobs are concentrated around. Okay. Coming back to our course contents. So here are our course contents. Obviously, machine learning is a huge area. It is impossible to cover everything in depth. So what we will try to do is we'll try to cover all the important aspects of machine learning that will try to easily fetch as a job. So basically, what we are trying to do here is we are not making you a complete data scientist. What we are making you is a data scientist with 3 or 4 years experience, or max to max 5 years experience data scientist. That's what we are trying to create in this 1.5 month course. So here are the topics. Roughly, we will be discussing 12 topics, okay, out of machine learning. And these 12 are kind of most of the times 70% of the, or 65 to 70% of the jobs that you are going to apply, you should be able to crack them by using these. Okay. First, we'll start with basic statistics. A lot of times, most of the students are not from statistics background. If you are from background, then well and good. Otherwise, we will assume that nobody has any background. We'll start from absolute bare minimal basics. We'll first build all those fundamental concepts so that we can understand advanced concepts later on easily. So we will start from very, very bare minimal basics, basic statistics. First, we will have our fundamentals correct. After that, we will get into data exploration, data validation, data cleaning. In the real world data science projects, it's the data exploration, validation, cleaning. That's where most of the time is spent. Even in the interviews, when you attend them, you will be tested heavily on these skills. After that, project will be allocated to you, project phase 1. In that project, you will be completing until, so in that project, a data set will be given to you, a real data set. Then you will be completing until the data exploration, validation, and cleaning. So some of you are asking me, sir, I don't want to show a lot of machine learning, but I still want to show a little bit of machine learning. Maybe you can show this as the bare minimal basic. You can say that this is what you have done. This is the place, or this is the part of the project that you have contributed until the data cleaning. Okay. And that's not very difficult. That's very easy. Then comes the basic machine learning algorithms like regression, logistic regression. Then applying those algorithms on our data set. So that will be phase 2 of the project. Understanding the concepts in the classroom, doing the exercises in the classroom is only 50%. Understanding those and applying them on your project will actually complete the whole learning. So you will learn here and apply them on the project. And then this is a continuation of the simple machine learning algorithms only. Decision trees, model validation, feature engineering. After that, project phase 3. Advanced machine learning algorithms. I think by here, the ADA guys will be stopping, but it is up to them. If somebody feels that they are understanding very well, they can, if they want to continue, they can continue. Advanced machine learning or black box methods, random forest, boosting, again, applying them on the project. Then comes the natural language processing, which is known as text data. On the non-numerical data, how do you apply machine learning algorithms? Because the rules will change there. Then the sentiment analysis, and finally testing of hypothesis. These are the 12 topics that at least we can justify in our experience. Now, what are the topics that are out of scope? Obviously, this is a huge field, and usually full data science course will take around 2 years to complete. Here we are giving almost 1.5 months, and we want to crack a job by showing this experience. So that is why some of the topics are out of scope. TensorFlow, you may have heard of it, artificial neural network, deep learning, model deployment, DevOps, SVM, all the other topics are out of scope. It is impossible that for a person with 4 or 5 years of experience has worked on every aspect of machine learning. That will be too hard to believe. Do you agree with that? You're saying that on your CV, I have worked on machine learning max to max 4 years, but I have worked on artificial neural network, TensorFlow, deep learning. I worked on random forest boosting. That will be too much to say, isn't it? It has to be believable. So it is a 2-phase approach that you have to follow. Maybe some of you will be showing a little bit of machine learning. Some of you will be like, depending on your confidence, if you are like some students, initially they told that they don't want to show machine learning, but later on when they learned this, they felt that they are very confident in machine learning. They have shown it and they have cracked the jobs even in the recent batches. So based on whatever is your understanding, based on whatever is your experience with the project, based on that, you can proceed further, and then you can find out what is the topic number until which you are very much confident. Based on that, we can show that on our CV. Okay. So there were some questions around what are we discussing, what are we not discussing, and these are the topics that we will discuss. And I'm not saying that you're 100% perfect data scientist at the end of this course. You're only 65 to 70% perfect data scientist, which means you will admit in the interview that only like some of the questions, maybe out of 10 questions, you'll be able to answer only 7. The remaining 3 questions, you will be saying that, sorry, I did not get a chance to work on that. Sorry, I never got it. Let's say somebody asks you a question on SVM. You'll say that, sorry, I never got a chance to work on SVM based project. Somebody asked you about TensorFlow. You say that, no, in my experience, I worked only on Python, TensorFlow. I have absolutely no idea, but I'm ready to learn. You can say like that. Okay. So basically here, the idea is not to give you as much subject as possible. That's not the scope, or that's not the aim. All of us, we came with what is our main goal. Yes, learning is one of the goals, but the main goal is job. Somehow maximize the chances to get the job. We want to spend less time, less concepts, but we want to show them on the CV and try to crack a job as soon as possible. Okay. These are the topics that we are going to discuss. Machine learning is a concept name. Okay. So machine learning, the process of machine learning is Machine understanding the patterns in the data, creating a mathematical equation so that you can use that equation for prediction. This whole process is known as ML. Let me explain once again. Machine understanding the patterns in the data. Actually, we make the machine understand those patterns. So machine understands the patterns in the data. You give the data. Okay. That means whenever a customer is taking more than 50 loans already, there is a high chance that he will go bankrupt. Okay. Machine understanding the patterns in the data. Now here I'm saying orally, but how do you reproduce that for thousands of customers? And this is not just number of loans. There are multiple variables inside that, right? Creating a mathematical equation out of it. So this all using all these variables, who will actually default, who will not default, creating a mathematical equation out of those patterns so that we can use that equation for prediction. Using that equation by supplying all the details of one customer. This customer has taken 15 loans already. This customer age is 35. This customer income is $12,000. This customer monthly utilization is he utilizes 60% of the credit limit. This customer has paid 5 times late in last 2 years. If you give all this into this equation, then you can predict whether he will be a defaulter or non-default. This whole process, this concept, this whole process is termed as machine learning. Okay.
And sir, what is the difference between like machine learning, deep learning, and AI?
All are
between these
same.
three?
All are absolutely same. There is no difference. These are different terms. Like machine learning is same as predictive modeling, is same as deep learning, is same as artificial intelligence, is same as data analysis, same as data mining, and so on.
So basically, these are the concepts only. Like
Concept. So basically, underlying concept is this one. We take the data, find the patterns in the data, build the strategies. Okay. And this can be named or termed as anything. Okay.
okay, so thank you, thank you.
One of the question in the chat window is what is the difference between data analyst and data scientist? As it is, there is not much of difference, but in the general notion, the general terminology, right now, data analyst is somebody who is mostly working on descriptive analysis, showing whatever is there, trying to describe what is there. Data scientist is somebody, data analyst generally uses Excel, SQL, SAS, Power BI, Tableau, those kind of tools, Python. Data scientist is somebody who is working on predictive. This is, let's say, showing what is the sales last quarter, last month, last year, or what has been the sales, all those things, showing them, describing what is the data. Data scientist is somebody predicting. If this happens, what is going to be the predicted value? If this happens, what is the predicted value? That is data scientist who's working on machine learning heavily with Python or machine learning heavily using SAS or something like that. That's the major difference. So data analyst is somebody who will be working on business intelligence tools, reporting analytics tools. Those are the tools. Data scientist generally works with this plus ML.